Hey guys, research starting now. Yay! So this is my mentorship group, or some of them. Not everyone could be here today. We're doing cyber defense, so going over some blue team skills and automation and that kind of thing. I'm really excited for them to share what they've learned. And I'll pass it off now.
All right, so yeah, we're just gonna show off what we did in the mentorship group. Yeah. So that's me. I'm Leah. Our first year cybersecurity major. I'm from New Jersey. What else? I play some violin. I do some infra. I do not like sabotage pizza. Yeah, that's my dog.
Let's go.
All right.
Oh, I got this. Wait. Yeah, it's on.
Hello, my name is Lukas Peters. I'm second year RITSEC major. I'm deaf with cochlear implants. I also know some ASL. Thank you. And I am from Ohio. And I like to play volleyball. Thank you.
Oh, hi. I'm Lily. I'm also a first year CSEC. I'm from Vermont. I play the violin. I like plants and Pepsi a lot, and I also like my pigeons, which two of my favorite are there, but they're dead. Anyways, I'm just saying.
Okay. Oh yeah. And that's Alex. He's not here. He's a CS major. That's the most important thing. Okay. On to what we learned.
Who's first? Oh.
So, yeah. We met once a week, and we started off talking about the MITRE ATT&CK framework. So, yeah, we just put, like, a few of the most important parts of it, I guess, are the most relevant. So, you know, reconnaissance, when the information on a system is actually found, I don't know, sorry. And then defense evasion is probably more applicable, as in, like, you know, what red team would do to mitigate or, you know, evade our cyber defense techniques.
Mm-hmm. And so learning the framework also helped us to learn what, like, in the eyes of the threat actors, what they would do, and then learning the framework would help us, like, figure out which areas we should focus on, or like any vulnerabilities that we should know about. And these techniques helped us to, like, solidify the defense. Yeah. Okay, so I made this image around it was after RITSEC. It was the time we learned the existence of Gumper. So there was not much we knew about Gumper at the time, but, like, I knew it was like a bootkit, so I just added, like, Gumper to the procedure examples. As you can see on the first line in the yeah. Yeah, it was basically the way I applied my knowledge about the framework.
Oh yeah.
Let's go. Oh. So, general stuff we learned. The basics. So, like, what to do, what is blue teaming, what scripts we could write. So, on the board is, like, some ideas we wrote down, discussed that we could do for scripting. We learned what syntax, like the different syntax, PowerShell versus Bash, and this was also right before RITSEC, so we learned, like, stuff we should expect from RITSEC. Yeah.
I don't know how to explain this. This is also some things we talked about in our meetings. That's all. Okay, now what we actually did after learning all these things.
Dang. Okay. So I did Windows scripting. I hate it. Anyways, so I didn't know what to do. So I did, like, that. So basically what I did was I checked, I had a code that goes through. You could put like a directory for it, and it goes through all the files in there, and it puts like a baseline for what it was. So basically, it does all the hashes, like edit history, all that stuff. And then I have another code or a script that goes and takes. Oh, so the baseline makes it into a CSV file. So I could go back and look at that. The checking for change, that's another script that goes and uses the CSV file, looks at the files, and then checks to see if there's a change. And then I also made it so that I could run it for whatever time I want. So for right now, I have it set for like every 10 seconds indefinitely until I stop it.
So I decided to do Linux because I like Linux. And yeah, like my thought process was at first, after researching all the stuff and seeing, what can happen, what can we do, I was like, I can make stuff, but it's not going to be original or, not in a bad way, but I couldn't think of anything super in depth. So I was like, okay, after I've practiced doing some simple things, what if I turn it into Ansible, because I want to get better at it. So that's what I did. And so these are just like the things that I looked over. I'll go over it more later, but I looked at very simple things. What kind of users are on the system, check if they're approved, as in like, do we want them there or do we expect them to be there? Same thing with cron jobs. See if any bad things are going on with that. Processes, what SSH keys are on the box, and then services reports. Yeah, this type kind of shows my development from kind of understanding it vaguely to it kind of clicked at some point. And then, I decided to throw in a little like overview of Ansible again, even though we've heard Jason Howe talk about it a lot. So you have, that's my kind of my files. So you have the playbook at first, which contains the Ansible plays, and that's like the main first thing that you would look at, where it compiles everything. Again, I'll walk through the code later, but there's like, I struggled personally with a lot of the vocab and differentiating all the words because host, groups, tasks, roles, it's all very similar in a sense. So I felt the need to like really look through that part. Inventory, it has hosts and then groups, which are lots of hosts, and then you have your roles, which I named Linux and Windows because I intended to incorporate release stuff in mine, but we need to work on our time management a little bit. So I only have Linux tasks, and tasks are like within the role, which I named, and that's the stuff that actually happens. That's Ansible saying, do this. And I also tried to, run it and implement it and test it. So I was like, okay, we have some OpenStack access. So I set up like a little network, but I had a lot of technical difficulties with the actual boxes, so that didn't work out, but I'll keep working on that.
Okay. What I did was like a all-in-one open like a command line interface application where you can have like logging and then monitoring from your server, and then you can have like deploy the client agents on the clients. I wanted to do this so you don't have to go to each individual computers and then figure out what is happening. And so how this works is that the server is listening on the port, and this can be quickly spin up on using Docker. And then the agent will be on a client's computer, which sends logs to the server. So for example, a file has been changed. If you want to send that to the server, send the differences between like the then and now to the server, and you can see the line of logs on your server. That's something I wanted to work on. It's still a work in progress. I wasn't able to finish it, but I do have like good plans for it, and I'm excited to finish it. Okay, so this is Alex. Alex is not here. He's unable to make it. We'll try to figure out what he's done. His title, Entire Injection Windows Driver. So very specific defense against a process injection on Windows. A cat and mouse game of hooking and unhooking. In kernel space, there's a syscalls, no matter how they're invoked. So there's a standard driver method called OB register callbacks. So it denies the process create thread, which is, I'm assuming, from process injection, and the process VM access to everyone. So the full access is given if the process hasn't started yet. And then he gave us this drawing. It does help a lot. So I'm assuming from the attacker in user space, it handles a request via syscall, goes to kernel. Yeah, okay. So he knows a lot more of this than we do, but we're trying. And then it denies the syscall, even though the attacker said pretty please. All right. I'm gonna just okay. So there's a few things that this blocks. There's a framework. Yeah. There's that too for you to read. We'll go to the next one.
Yeah, just check out his GitHub. Talk to him about it. It's cool stuff. Let's take a little look at my Ansible that is untested. So, again, starting off with the playbook, this is basically where. Also, it errors because I don't have Ansible on this laptop, so it's not wrong. So basically, yeah, I split it into Linux and Windows, anticipating that it would be able to have both of those. But essentially, you have this is the name that I give it, and then the hosts Linux again. There's a lot of repeats. Become yes means that Ansible escalates privilege when necessary, which is like sudo for Linux. And then roles is linking it to here, so roles over here. And then tags basically say that when you're running your Ansible playbook, you can specify. The never says that it will never run unless you specify this tag, for example, for this type. Then let's look at inventory. This is where I defined the boxes that I would be running it on. So it's just, it's a bunch of like stuff that you have to do. You have to say, same thing again here. It's like you are sudo, your user, your SSH key, that's how you're getting into the Linux box. And then password and the IPs, obviously. For Windows, you're just getting in through remoting protocol instead of SSH. And then the actual stuff is in roles. So, for example, I split it. I think I was following the suggested organization, which is to have the main, and then here I'm just referencing all of the tasks like this, because you could throw them all into one, but sometimes if a certain task, requires multiple steps, you would want to split it up into different files. So, yeah, for example, let's look at my users. Firstly, we name the task get list of users from the system, and it's just running the shell command to check etc password and then get only the first part, which is their usernames. And this means that it's assigning this output to user list. And then we're gonna say Lily, Lucas, and Chase K are allowed to be on the system. So after that, we just figure out, after we have all the users, who's approved, who's not approved, get the difference, and then in addition to that, disable the ones that we don't like. It's pretty straightforward. And then, yeah, it's just about, for me, it was about learning stuff like this, which means like, if there are unapproved users. I can show, I guess I'll show this one. It's also very simple. I ended up throwing a lot of stuff just as like a shell command. And then again, yeah, it does this. You read it, and then you check the cron tab in another command. This is something more interesting. Maybe this one. Shell. Okay, hold on. Okay, this is fun. So let's say that we only want, SSH, HTTP, HTTPS. So that's going to be what we set as our approved ports. And then, where is it later on? We run a shell command, get the open ports, and then, again, very similar to what I was just showing, you get the difference. And for this one, you kind of let the user do what they want about it. So I would just display it. But yeah, is there any questions about this? This is definitely a work in progress, and I would love to test it as well. So, yeah. Okay. Anything? I guess our takeaways, right? Like, anything, you guys? Okay.
One takeaway is that like we were able to like get in the mind of like the blue team, where like were to expect what the red team would do in the competition. The reason why these are useful is because you can use these in like 5-minute plan for the competitions, and you can secure your topology much faster. This mentorship basically helped with that. Yeah. So thank you right now.
Thanks.
And Zach, thank you.
Okay.
Thank you.